there, welcome to today's Q&A. This is Selena here, and we are on Genetics at a Glance. And I'm going to be answering some of the questions that I see in the forums a lot, or I get messages on, or that I hear from different clients, or even sometimes what we see in the practitioner forum. So the question I have today is, can someone talk about having an MTRR SNP and also an MTHFR SNP? Having those together, what are the implications of that, and what does that mean? So to do that, we're going to look at this, one of my favorite charts, and that is one of Ben Lynch's pathway planners that delves into some of the key pathways surrounding what we often hear about, like MTHFR. And that is our methylation cycle, our transsulfuration cycle, and our biotin cycle, or our detox and neurotransmitter cycle. So let me share my screen here, and let's see if we get the right buttons clicked. Okay, so here is the pathway chart. And let me zoom out first here a little bit so you guys can see all of it. So this is a really good one because it has those three cycles I just mentioned. The top here is the folate methionine. They make up the what is mostly considered the methylation cycle. The bottom right-hand side down over here is the transsulfuration, or like the detox cycle. The bottom left is a biotin, or the neurotransmitter cycle. However, it makes something really, really important called NAD, and it even goes past that NAD, which is critical in so many different processes in our body, especially things related to our immune response and for detoxification. But we're going to zoom in on MTHFR and MTRR, and those are here in those top two cycles. So the folate and methionine. So down here on the left is MTHFR. That is kind of like the bottom of the folate pathway. At the top of that is where folate, like from our food, comes in, goes in through folate receptor 1 to DHFR, goes all the way down there to MTHFR, and it makes something called methylfolate. The MTRR is over here a little bit on the right here. You can kind of see where my mouse here is, hopefully. And that is in the methionine cycle. And it's in a little mini cycle here inside of that methionine cycle, and that's the methyl B12. This cobalamin is B12. So the MTRR makes methyl B12, the MTHFR makes methylfolate. So if all is working well, these two things combine at MTR along with zinc and homocysteine to make methionine, and it just makes this methionine cycle go around and around. Now, one thing you're looking here at this chart is you'll see the cofactor. In green are these cofactors right here next to the genes, and it has like this little kind of curved arrow, and then the cofactors listed. And then you will also see things like in purple, these are things that will slow down that gene. So whether you have a SNP or not, it will slow down that process. Sorry about that. And so, and then there's also some things like the orange. Those are things that will naturally speed up those processes. So let's say if you didn't have any SNPs whatsoever, these are things which will influence those genes. And what the SNPs do, which are just variations, they are not mutations, they are not like a disease, these are just variants that it can either slow down or speed up. And so the MTRR and the MTHFR variants there are thought to slow those processes down. So those are naturally going to slow those things down if you have variants or have the potential to have those things slowed down. Now the MTR, and I know this kind of goes aside from our question, but the MTR is one of those genes where SNPs are thought to speed that one up. But if you have the MTRR and the MTHFR, then potentially you're going to be a little bit slower at that cycle of metabolizing folate and metabolizing the B12. So that can make you more predisposed to having challenges there in those, which in turn have a domino effect of being able to produce methionine, which in turn makes SAMe. And you'll see that over here, the far right. And I'm going to move my screen over a little bit here, or maybe move this chart. Right here, the SAMe is SAM. Usually you're going to see it at capital SAM and then lowercase e, and that's SAMe. SAMe is something that's used throughout the body in many processes, especially in our neurotransmitters, but also in our gallbladder and things that are pertaining to PEMT. So SAMe is one of these things that's a vital part that we need to make sure that this methionine cycle is working so that we can support other pathways and other processes in our body. SAMe is also needed for making this methylcobalamin, the cobalamin cycle, the B12 cycle to work. So not only is SAMe made over here, but it's also needed for that to work. So it's a lot of catch-22s involved. So if you have a problem where you can't make enough SAMe, and then you don't have enough SAMe to make that methylcobalamin, and you see how that's kind of like a double whammy. And when we have those kinds of things, it's usually more than just 1 + 1 = 2. It's like 1 + 1 = 5 or 10 or 50 or 100. And so there's usually a synergistic effect or a multiplying effect whenever we have different SNPs where we have these pathways are burdened. So what can you do about that? So when I see SNPs like this, the first question I'm going to ask is, are they expressing? Because just because we have a SNP does not mean that there is going to be a problem. We just may be predisposed to having a challenge there. But these SNPs are going to be influenced by the things around us. So whether it's our environment, whether it's like toxins, the foods we eat, the stresses we have, those sorts of things will influence the genes. And so it's kind of a bidirectional relationship where, you know, we influence the genes, well then the genes now are influenced in how they respond, which means how we are able to respond to those stressors. So it kind of goes both ways, and that's where there's a lot of catch-22s. So I like to first let's look at the stressors that are involved, and let's remove as many of those things to put the least amount of burden on these pathways. And then secondly, to look at, are we getting the cofactors needed? Like just giving methylfolate, just giving methyl B12 doesn't really help if you don't have enough zinc to make all of that work. If you don't have enough magnesium and stuff to finish that process at the methionine and keep things going, the NAD, if that's not getting made over there in those neurotransmitter pathway, or none of SAMe or the FAD or the B6 down here, you've got homocysteine is another thing. That's a lot of questions on that. And that's like a whole topic in itself. So it's really important to look at the bigger picture. So if you have these SNPs, to say, okay, I've got potential here to maybe I have a 2-lane highway versus a 4-lane highway, or I have a 1-lane highway versus a 4-lane highway. But we have to remember that a 4-lane highway can be dead slow in the middle of rush hour traffic. So just because we don't have a SNP doesn't mean that's going to be the greatest thing on earth. And just because we don't have a SNP doesn't mean that it's not going to be perfectly fine and adequate. So it's about putting it into context and to look at that bigger picture. So this is, like I said, Ben Lynch's pathway planners. You can usually find them online. I think it's like $45 for his complete set at seekinghealth.org. There's a lot of videos, resources, and I can post links on that. I will post them here below in the description of some of my favorite resources on really delving into nutrigenomics, to genomics, to the immune response, because these kind of pathways are key when it comes to our body fighting something, whatever kind of stress it is. There's going to be an immune or inflammation response. It's just a natural response. It's what our body does to help keep us protected and living and all that sort of a thing. So looking at how those things work can really help for you to understand and to put into context your particular situation, because what may work for you may be different from me, even though we may have very, very similar SNPs, just because we have different things surrounding us that are putting a burden on those SNPs. So I hope that answers the question on how MTRR, having a homozygous there and a heterozygous MTHFR, how those two work together, what that actually means, and what you can do about it. You're always welcome to reach out to me with any questions. You can find me on Facebook or message me, email me. And again, if you have any questions, let me know, and I will see you next time. Take care.